Okay, so we will revise your Sec 3A Math. The first chapter that you see or you need to know is your simultaneous equation. So typically what you need to know is that elimination will not work. Okay, we have to use your substitution. Second thing, you also need to know that we can use simultaneous equations to find the intersection of two lines or two curves. This is very important in certain chapters like our quadratic function, which we'll be doing later. Okay, also in your coordinate geometry. Okay, so simultaneous equation is a very important tool. You must be able to use it freely anywhere. Okay, so let's just start with the first example. So example, the composite function is formed by two squares, length of x and y respectively. X and y are integers. So this word integers will allow you to check whether your final answer is correct or wrong. Okay, so if you calculate your answer of x and y, they are fractions or decimals, then you know that something is wrong and you have to be. Okay, so for this question, the area and the parameter is this and this respectively. So we know that we need to form an equation in this case. So the easier one to form is of course area. So area of this big square is actually just x squared. The area of the small square is just y squared. So x squared plus y squared is equals to 136. Okay, next the parameter is 52. So parameter is made out of this, 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 this. So the blue color one are all y and the red color one are all x. So the only part that is left not calculated is actually these two parts. So what is actually these two parts? These two parts is actually your x minus away your y, you get the green part. Okay, so this is where we can form the next equation, 3x plus 3y plus x minus y is equals to 52. Okay, so simplify. We will not start until we simplify our equation. So from here we know 4x plus 2y equals to 52. Simplify further, divide by 2. Okay, so we know that we don't use elimination, so we better make y the subject. We do it this case. So that's my equation 1. This is my equation 2. Then sub 1 into. Okay, so x squared plus 26 minus 2x bracket square equals to 136. From here, you should do your expansion properly. Make sure you don't do it wrongly. So 26 squared is 676 minus away 104x plus 4x squared. Okay, put them together, 5x squared plus 540. Wrong. Minus 104x plus 540 equals to 0. What do I get when I factorize it? See. You factorize this, you will get x minus 10 by x minus 44 by x minus. Okay, so from here we know that x is equals to 10 or x is equals to 54 over 5. When you get 54/5, you can reject it immediately because we know that x is the integer. So when x is 10, y is simply 26 minus 2 times 10, y is just 6. Okay, so x is 10, y is 6 is the answer for this question. Okay, any question? Okay, so this is a very simple technique that you should know. Okay, so yeah, with this, I think most of you know how to do this. It's just a refresher. So with this, you will be able to do question 1, 2, 3 yourself. Okay, so please do it at home and submit it when you're done. I'll move on to the next one. Okay, your next skill, this is a very important skill, quadratic inequality. What is quadratic inequality? As long as you see something square with an inequality, this is what we call inequality. This is what we call quadratic. Okay, we must draw a graph and solve it. Okay, you cannot use your algebra 100% to actually find your answer. Yeah. Okay, so how do we represent the solution? What does solution mean? Solution means you are supposed to solve for x. Okay, so to solve this, because this is a simultaneous inequality. Why is it a simultaneous inequality? Because I have two inequality here. So it will be, I have to break them up. And it's not an or, you have to satisfy both of them. Okay, so what you need to do is to factorize. Okay, and as far as possible, keep your x squared positive. Okay, over here I can factorize straight away. Okay, this one you factorize x minus 3, x minus 5. Okay, from here, once you factorize, you have to draw your graph. Okay, so this is 0, this is 8. So because it's a positive x squared, that's the reason why we keep it positive x squared. So that is a smiling face. Okay, so which region do we choose? We choose the negative region because this is less than or equal to 0. So this is the region we choose. For this, the 2 points is 3 and 5. Again, it's a smiling face because it's positive x squared. However, this one we choose the more than 0 one. So imagine this is your x-axis, more than 0. Your y value more than 0 means it's above the x-axis. So these are the region that we choose. So for this part, right, my answer will be x is less than 3 or x is more than 5. And x is between 0 and 8. Okay, you see, in the first place, we break this into two parts. So now what we need to do is we have to combine them together. So how to combine them together? Imagine this is asking you, oh, your ice cream need to be at this temperature and your ice cream need to be at this temperature. What temperature can you put? Okay, so if you cannot see, right, the thing that we do is actually just to draw a graph, a number line to see. So this is my number line, got 0, 3, 5, 8. So it must be less than 3, it must be more than 5, and it must be between 0. This one got underline, this one got equality. So with equality, I will shade the circle until 8. So what I find is, where does this x value overlap each other? So the places where they overlap each other is actually this part and this part. Okay, so the n, now I combine back together. I break them apart. Now I need to combine them together. So the final answer for this is actually x is between 0 and 3. Okay, you must be careful. It includes 0. However, it does not include 3 because it does not include 3 over here. Or does not include 5, but it includes 8. Okay, but is this the answer? No, because the question asks you to represent it on a number line. And this is not actually the solution. This is like a working like that. The solution, right, should look like that. This is my number line, 0, 3, 5, 8. I should be drawing this. This is my solution. Okay? And determine if x equals to 5 satisfy the inequality. No, because 5 is not included in the final answer. So x equals to 5 does not satisfy the equality. Okay? Ken, any questions so far? So inequality, quadratic inequality will just appear here and there in any question one. You have to remember that you need to draw your graph. Okay? If you don't draw your graph, you will not be able to solve it. This is very wrong. Today, if you were to do this, is very, very, very wrong. Absolutely wrong. Don't tell me x squared minus 2x minus 3 is less than 0. You do this. This is wrong. Okay? So we cannot solve using algebra like that. We have to go and draw our graph and solve. Okay? Can. If not, then we move on to the next chapter. Okay. Okay, so attempt question 4, 5, 6 yourself. Okay, so all these things, the first two are just some techniques that you need to know. So it can appear anywhere in the question. So not really like a question by itself during your exam. Okay. Okay, so now application of completing the square. So what you do in A math is typically the application. Why? Because completing the square itself is already done in E math already. So what's the difference between E math completing the square and A math completing the square? It's the coefficient of x squared. Okay, so the coefficient of x. Oh shit, this one is wrong. This one typo. This one changed to x squared. the coefficient of x squared must be 1 before you can start completing the square. Okay, so what are the purpose of completing the square? It allows you to find the maximum and minimum point of the quadratic function. Second, it can be used to determine whether the thing is always positive or always negative for values of x. Okay, so where else? What are other methods to find maximum and minimum? Okay, of course, when we see maximum, minimum in a question, we must also relate it to differentiation. Of course, you can also use differentiation to go and find the maximum or minimum point of your completing the square. However, the question can phrase it in such a way that you have to use your completing square form to do it. Then you will not be able to use differentiation. Okay, so differentiation will allow you to find maximum minimum point of your quadratic graph also. But it depends on how the question is being phrased. For example, let's look at this example. Part 1 asks you use completing the square. Part 2, they basically just ask you use answer in part 1 and explain. Then you got no choice already. If you use differentiation, you don't get any marks for part 2 because it is clearly stated that you have to use part 1 to do it. Okay, so first thing, so part 1 express this in this form. So this form is actually what we call the completing square form. Okay, I will show you today if you really don't know how to complete the square, how can we do it in another way? Okay, so first thing first, factorize 3 because why? I need the coefficient of x squared to be 1. Next, now it's 1 already. So what square contains this? Okay, x minus 1 square contains this. However, there is an extra 1 square. So we subtract away the 1 square. Okay, and then this is plus third. Now we expand it in, we get this. Okay, if you want to check whether you are correct, just do a quick expansion. Expand this is x squared minus 2x plus 1. Then you times 3, it becomes 3x squared minus 6x plus 3. Then you got this plus 2. So can you see that the outcome is the same? So this means that you have done your completing the square correctly. Okay. So this one done. Now let's move on to complete the other one. Okay, again, I expand this is x squared plus 4x plus 2 squared. So I subtract away the 2 squared. I copy down the plus 3. Okay, this is what I get after I complete the square. Yeah, I answer a call. All right, so I have completed this two. Now, using your answer in part 1, I explain why the two curves will not intersect. Okay, so again, we must understand why they ask us to complete the square, because completing the square can find the maximum, minimum, and whether is it positive or negative. But in this case, I definitely not interested whether this is positive or this is negative, because positive and negative doesn't really tell me whether they intersect or not. So the only other thing that you can think of is your maximum and minimum. So this one, since I'm doing part 2 now, okay, since coefficient of x squared is more than 0. Okay, so because this is 3x squared is more than 0. From this part, I will know that the minimum point is actually 1, 2. Remember, from the completing the square, the x is 1. When this thing is 0, that is where you get your minimum point. So x has to be 1. And when this is 0, the y coordinate will be 2. Okay, for this one, since coefficient of x squared is less than 0, the maximum point is negative 2, 1. Okay, so since the maximum point is less than the minimum point, okay, the 1 is lesser than the 2. Okay, imagine your minimum point only end at y equals to 2, then this one maximum can only reach until 1, comma, the graph will not intersect. Okay, you can see I'm using maximum, minimum. One of them, the maximum is until 1. So graphically, this is how it looks like. Just imagine my graph is a set phase graph. It reaches this point only. This is my 1. So the graph reaches like that. Okay. Then the other graph, this one, 3x squared minus 6x plus 5. This is 2. It looks like that. Okay, so when the minimum point is more than the maximum point, they will definitely not intersect each other. Am I going too fast? Okay. Okay, any questions so far? All good? Okay, so next one. So you will go and do question 7, question 8, and question 9 yourself. Okay? And we shall move on to your real thing. These are questions that will definitely come up for your exam. Okay, so discriminant, what is our discriminant? Discriminant is your b squared minus 4ac. Where do you see your discriminant? Discriminant comes from where? Discriminants come from your quadratic formula. Okay, and when can you use your quadratic formula? When you have a quadratic equation. So you must remember that this is what you need to find. I have a quadratic equation must be equal to 0. Then I try to find x. When I try to find x, the question will tell me how many x answers do I have. Whether I have 1 x answer, 2 x answer, or 0 x answers. And what truly affect that? The thing inside the square root. If the thing inside the square root is negative, then I will not have any x answer. If the thing inside the square root is 0, then I will have 1 x answer. And when the thing inside the square root is more than 0, I would have 2x answers because I have 1 plus answer and 1 negative answers. Okay? Next, always positive also means b squared minus 4ac less than 0. Why is it so? Always positive graph will look like that. It will not cut the x-axis. So when your quadratic equation equals to 0, you are not expecting yourself to get any x-intercept. There is no x answer. That's why the thing inside the square root must be negative. Okay, always negative is the same thing. It's a set phase graph. Again, it does not cut your x-intercept. So when your equation is equal to 0, you should not get any x answer. And how do you not get any x answer? The thing inside the square root, which is your discriminant, must be a negative number so that when you press your calculator, square root a negative number, you get your math error, there is no answer. Okay, so in this part of the chapter, we use quadratic inequality a lot, your simultaneous equation, and occasionally completing the square. Okay, so let's take a look how we do the question. Okay, example. Okay, there are 2 examples because there are 2 different types of question. So this first example, must learn how to read the question. The question says, find the range of values of k. Okay, the curve and the line do not intersect. So what we do is we will assume they intersect first. Okay, so when they intersect, what happens? When they intersect, we need to solve simultaneous equation. So 2y minus 4 over x equals to k is my first equation. My second equation will be half x plus y equals to k. I think I make k y the subject, so y equals to k minus half x. So now we assume the two graph intersect. So when I sub it in, I have 2k minus x. I sub inside here. Minus 4 over x equals to k. What I need to try to form now, remember, if I want to find my discriminant, I need to form my quadratic equation. And this x is stopping me from doing that. So what should I do? I multiply by x throughout. Okay, now again, I prefer to make my x squared positive, so I bring everything to that side. When I bring this here, it becomes minus kx plus 4. Okay, so imagine now, okay, so this step that I write in red is not needed, but it allows you to understand better. So now imagine I want to find the intersection, means I need to solve for x, right? I want to find the intersection where the curve and the line intersect, means I need to find x, right? So when I want to find x, I will use the quadratic formula. Minus b plus minus b square minus 4ac over. So this red color step is not needed one. I'm just trying to show you something. So k plus minus, this become k square minus 16. Okay, so based on this, how many x answer am I supposed to get? Based on the question, they do not intersect. Means I should not get any x answers. And how do I not get any x answer? So since they do not intersect, okay, my discriminant is equals to 0. Is less than 0. Okay, so you can see the discriminant is actually the k square minus 16. Okay, so the red one is not needed one. However, if you cannot or you don't feel very comfortable jumping from this to this, please go ahead and use your quadratic formula and understand what is going on. I don't want any x answer, so this thing in the square root must be a negative number so that when I square root the negative number, I get math error. Okay, reach this stage already. This is called a quadratic inequality. As mentioned just now, whenever there's a quadratic, there is an inequality, we have to draw our graph and solve. And how to factorize this? This is actually your a square minus b square become a plus b, a minus b. So draw graph, negative 4 and 4, k square, so it's a smiling face. I want the negative region. So this is the region I choose. So my final answer for k is negative 4 to 4. Okay, what else did the question say? Represent the solution on the number line. So what you should do is you draw a number line. This is k, this is negative 4, this is 4. Your k is between negative 4 to 4. Okay, so this is represent the solution on the number line. This is find the range of value of k. Okay, like I said, this is not needed, this redundant one. You can skip this step. However, this step actually will allow you to understand what discriminant is about. Okay? Okay, so this is a very typical question. So when we have two graphs, that's what you do. Okay, next, can I move on? Done. Anyone not done, you better say so, so that I will wait for you. Done? Calling once, twice, thrice. Bye. Okay, next. So what's the difference between this question and just now the question? Just now the question is find the range of value of k, meaning only a few value of k will satisfy that thing that they will not intersect. This question is show that they will intersect no matter what value of k you have. That means you are not trying to solve your inequality. You're trying to show that they are always positive. You're not trying to solve. So a show question is different, but then still the same thing. First thing first, we find where they intersect. So to find where they intersect, we solve simultaneous equation. And rearrange into a quadratic formula. I prefer my x squared to be positive, so I bring it there. Okay. So now, when you try to solve for x, okay, again, this red color one is not needed. When you try to solve for x, your b in this case is negative k plus 1. Okay, so this is what you have. So what the question is trying to say that, oh, you must tell me, you must show me that this thing inside the square root will always be more than or equals to 0, must be positive. Otherwise, if it's not positive, they won't intersect. This is what the question is trying to show to us. Okay. So your b square minus 4ac will be equals to this. So you're not trying to solve. You cannot write this statement down. You don't tell me you write, you don't do like that. This is not finding, you're not trying to find k. So please don't do like that and try to solve for k. You are not doing that. They are not asking you to do that. Okay? And they are telling you all the k are correct. They want you to show them that all the k's are correct. So what you need to do is, how do we show something is always positive or negative? Completing the square. Okay, just now we go through a completing the square. So expand this become k square minus 2k plus 1 minus minus what? Minus 84. Okay, they would intersect. It's always positive. Correct or not?
Isn't it plus 84?
Plus
它有 negative 7
also negative 7 Okay. Okay, so this is negative 7, so this is plus 84. Okay, so over here, at this case, by writing like that, I still cannot conclude that it is always positive. Why? Because there's this part that is negative to k. Okay, so unless you tell me you suck all the k in the world, you let k be 1, let k be 300, let k be 0.01, and show me that all the number in the world will always be positive value for this. However, it's not possible for you to test every number in the world, correct? So the only way to do it is actually to complete the square. So k minus 1 square minus 1 square. K minus 1 square, you will get k square minus 2 square. There's an extra 1 square, so we subtract away. And then you get this k minus 1 square plus 84. Okay, so now it's very clear. Since k minus 1 square is more than or equals to 0. Okay, anything square must be more than or equals to 0. K minus 1 square will be, then I add 84. It will be more than or equals to 84. Correct? When it's more than or equals to 84, I can simply say that it must be more than 0. So my b square minus 4ac will be more than 0. Okay, therefore, Because b squared minus 4ac is more than 0, therefore the curve will intersect the line. Okay? Meaning this thing, no matter what k you put inside, this thing will become positive. So you definitely have an answer for x, and that's why they intersect.
Wait, I don't get it. Like, why when it's positive, you will sure intersect the line?
Because when you do square root, a positive number got number come out or not?
Yeah,
This x, what are you finding? This x, what are you actually trying to find?
intersect.
Where they intersect. When you got a number, when the number 5 appear, when you press calculator, 5 appear, what does it mean?
Intersect at 5.
They intersect at 5 lah. So this thing is positive, means you got the answer to come out what? If this is negative, you square root negative, you will have answer for x or not?
No.
No lah. So this red color step is always neglected, or you don't really do a lot of this because it's a little bit waste of time. But actually, if you use the quadratic formula, you can actually see your discriminant and understand discriminant a lot better. Okay, can I proceed? So actually, you can see that every questions here, I actually put the marks allocated for that question, so you can actually gauge. And so every 1 mark, you should take 1.5 minutes to complete. That is the exam standard. Okay, but it's not really true lah, because in exam, some of the questions, you take lesser time to complete. That will compensate you on questions that you need to take more time to complete. Okay, but this is just a very general guideline. Okay, I move on. So the next one is your application of quadratic function. So it involves your quadratic graph, your minimum and maximum point, your y-intercept, your x-intercept, and your line of symmetry. So what you need, complete the square, quadratic equation, maybe discriminant, not really that much. Okay, so let's take a look. This is actually relatively easy chapter. Okay, so a ball is thrown from a cliff overlooking the sea. The vertical height of the ball above the sea is h. Given that h is this, find the height of the cliff. So we must understand when t must represent what? You must always read the question, what does t and h represent? T represents the time after the ball is thrown. That means when the ball is released from the hand, then your t will start. And what does h represent? H represents the height above the sea. Okay, so the height of the cliff, that means what? This picture of the height of the cliff, okay, just imagine you're standing here and throw. Okay, so at this point, when you haven't thrown, what happened? When you haven't thrown, you are on the cliff, correct? So what is the important thing in here is we don't care the person height. Just ignore the person height. Just imagine the ball is on the cliff. Okay, and it's being launched on the cliff. So before it's launched, the t is 0. So what you need to do for part A is as simple as when t is 0, my h will be 20. So the height of the cliff is 20 meters. That's all. Okay, because the thing haven't thrown yet, so your t is 0. Next, by expressing h in completing the square, determine whether the ball can reach a height of 65 meters above the sea. So complete the square now. So again, the coefficient of I factorize 8 because my coefficient of my t square have to be 1. So this become plus 36 over 8, 9 over 2. Then this one become minus 5 over 2. Okay, so now complete the square. What contains this? T plus 9 over 4. Just divide by 2. Okay, and what do? You subtract away the extra square, which is 9 over 4 square. What do I have here? 81 over 16. (81 plus 4).
Negative 121 over 16.
Negative 121 over 16. Okay, then now we multiply the negative 8 inside. Plus 121 over 2. Okay. So what is the purpose of completing the square? So first identify this negative 8t square means it's a set phase graph. So I'm talking about maximum point. So the maximum point is negative. Wait, salah. Oh, I copied the question wrongly. This is plus. This is minus. Okay, why I realized I made a mistake because if that thing is plus, right, my answer will be negative time, which is not possible. Okay, so that's where I realized something is wrong. Okay, so now my time is actually 9 over 4. Then what is my 121 over 2? Okay, so from here we know that the maximum height is actually equals to the maximum height that the ball can do is 121 over 2, which is 60.5 meter. So we conclude that therefore the ball cannot reach 65 meters. Okay. So this is where completing the square comes in now. Huh? Any questions so far? So in the first quadratic function chapter, it is all surrounding using quadratic formula. From quadratic formula, you have your discriminant, and completing the square is a very useful tool. Today, let's say they never asked me to complete the square. Would I be able to determine the maximum height? I can. We can use differentiation. You can see that h is equals to negative 8t squared plus 36t plus 20. So how do I find maximum height? I need to differentiate one time. So dh dt, negative 16t plus 36. So when dh dt equals to 0, this is to find maximum or minimum. So I know that 0 equals to negative 16t plus 36. 16t equals to 36, t is equals to 9 over 4. So I sub it back into my h. You will get your 121 over 2. Okay, how do you prove that it's maximum? Differentiate your dh dt again, you get negative 16 less than 0. Therefore, h equals to 121 over 2 is maximum height. However, you can see how the question can be phrased such that you got no choice but to use completing the square. Okay, you can use differentiation to check your answer. And actually, differentiation is a more elegant way of solving, nicer lah, I feel, and easier to do the algebra. Okay. So no choice because they say completing the square, you have to do that. You have to follow what they say. Okay, any question? Okay, no, then I will move on. I'll move on. Anyone still copying? Okay, so go and do question 13 and 14 yourself. I will go on to the next chapter already, polynomials. Okay, in polynomials, there's 2 to 3 parts. Okay, the first part is called remainder theorem. So what is remainder theorem? Remainder theorem says that if fx is divided by x minus a, the remainder is fa. So how does this comes about? So we must remember this relationship. This is what I call the divisor. This is what I call the quotient. This is what we call the dividend. And then when you do your long division, this is called the remainder. Okay, so how are these related? So this is how remainder theorem comes about. It's because of this relationship. So this relationship is such that, remember when you do in primary school, right? If this is 5, this is 3, this is 1, this is 3, this is, we can say that 5 is equals to 3 times 1 plus 2. So same here, we will have this relationship, the dividend is equals to the divisor times the quotient plus the remainder. Okay, and dividend is typically my fx. Imagine now the divisor is x minus a. Okay, so if my divisor is x minus a, my remainder will be a number. Your remainder has always one power lesser than your divisor, meaning if my divisor is x squared, my remainder will be in the form of ax plus b. If my divisor is x cubed, my remainder will be ax squared plus bx plus c. Okay, so you can see this. And what we always want to get rid, the irritating thing is this quotient. So how do I get rid of this quotient? I just let x become a. So when you let x become a, this becomes fa. This becomes 0. 0 times quotient will be 0 plus remainder. So this is how remainder theorem comes about. The remainder is actually equals to fa. Okay, why fa? Because we let x be a so that this thing becomes 0. So 0 times quotient, it will disappear. Okay, and what is factor theorem? Factor theorem is just a special example of special case of your remainder theorem where the remainder is 0. Okay, no remainder meaning is a factor.
So what is the hashtag one?
Number.
Oh, okay.
Okay, so this is how remainder theorems comes about. If you really don't know how to do all this, what this divide by that, this is the basis that you start from. You start from this, you can solve any polynomial question. Remainder theorem and factor theorem are just some shortcuts. Okay, so let's take a look at some example. Given that px is this, has a factor of this, and a remainder of this when divided by this, find the value of a and b. So px is this. So what do? I find p1. What is p1? P1 is actually the remainder, right? When it's divided by x minus 1. So p1, I sub it inside, it becomes 2 cubed plus 0 plus a plus b. And we know that since x minus 1 is a factor, the remainder will be 0. That means this thing is equals to 0. Okay, rearrange our simultaneous form nicely. Then we proceed to the next equation. So we got a and b. When you see a and b, you know you need to form another equation. Okay, so next, leave a remainder 21 when divided by x minus 2. So now I know I let x be 2. So it becomes 3 cubed plus 5 plus 2ab plus. So this is the remainder when it divided by x minus 2. The question also said that the remainder is 21. So now I know that this 32 plus 2a plus b is equals to 21. So 2a plus b is equals to negative 11. So this is my equation 1, equation 2. I just take 2 minus 1, I get my answer. So A equals to negative 3. So when A is negative 3, B is just equals to negative 5. So this is what remainder and factor theorem is. So the first part is actually me applying factor theorem. Okay, so if you are a bit confused why like that, let's take a look at the long way of doing. So when this is divided by this is my divisor, this is my dividend. So what is their relationship? Px is equals to x minus 1 times quotient plus remainder, correct? So imagine now I want to get rid of the quotient, I let x be 1. So let x be 1, this become P1. Okay, you can see P1 is actually this. And this thing is just 0 because 1 minus 1, 0, 0 times quotient will be 0 plus remainder. So you can see that P1 is actually your remainder. And what is your remainder? Because x minus 1 is a factor, the remainder is actually 0. That's why P1 equals 0. Okay, the long form for this part is what? When this is divided by x minus 2, the question says that the remainder is actually 21. So remainder is 21. So to get rid of the quotient, we let x be 2. So you can see that this becomes P2 and this becomes 0. So P2 is just equals to 21. And P2 is just this thing. And then that's how we form the second equation. Okay, but the blue one, we don't write the blue one down. Sometimes, unless you really don't know, because it's very time consuming. You can see there's so much things to write compared to the red one. But to understand that is what is actually going on. The red one is just a shortcut. But you're expected to use the shortcut because of time constraint. Okay, I think remainder and factor theorem is something that you all are more familiar with. All right, so let's move on. Okay, so do 15, 16, 14. Actually, I think it's a giveaway because it's just forming equation and use simultaneous equation to solve. Just be very careful with your steps. That's all. Okay, next, solving cubic equation. So what is a cubic equation? Cubic equation got x cubed, got. Okay, as long as got x cubed, that's called a cubic equation already. Whether you have this doesn't really matter. Okay, so how do we solve a cubic equation? We do it like how we do lah. We need to factorize, then we can solve. Okay, it's always factorization, then it can solve. So the other side must definitely be 0. Okay, so yeah, so how do we factorize? It's not like your quadratic equation. Quadratic equation, you can very easily guess and check and get your answer, right? You can easily see and write down the answer. Cubic equation, not so easy, what? So how to do it? We have to guess a factor. In this generation with your calculator, we don't really guess an answer. We just use your calculator and pretend to guess an answer. Next, you do long division to find the other factors. Lastly, once you factorize, you solve it like how we factorize. Okay, so let's take a look. How do we do it? Okay, so part A is very like our factor and remainder theorem. So first thing, x minus 4 is a factor. That means when fx is divided by x minus 4, the remainder is 0. So I find f4. So f4 is equals to 9 times 4 cubed plus 16a minus 4 times 23, 92 plus. So 4 cubed is 64. This is 576. So this becomes 16a plus b plus 484. Okay, and we know that x minus 4 is a factor. That means 16a plus b plus 484 is actually equals to 0 because this is the remainder when you divide by x minus 4. So we will have 16a plus b equals to negative 484, equation 1. Okay, next, it leaves a remainder of negative 20 when divided by x plus 1. So now it will be f negative 1. So f negative 1 will be negative 9 plus a plus 23 plus b. So this one will become a plus b plus 14. And I know that the remainder is negative 20. So a plus b plus 14 equals to negative 20. So a plus b equals to negative 34. That's my equation 2. Okay, so how to solve them? I just subtract equation 1, subtract equation 2. So 15a is equals to negative 454. Yeah, negative 450. 1 minus 2. Okay, so a is actually equals to negative 30. And b will be equals to 4. Minus 4. Okay. So you can see over here, they don't really test you much on simultaneous equation. I really need to use substitution to do it. Actually, elimination is a lot faster. Okay, using the value of a and b found in part 1, solve the equation of this. So now fx equals to 0, meaning this is equals to 0. So I put in my a, I put in my b. So how do I solve for x? The good thing is they already tell me x minus 4 is a factor. So I don't need to guess anymore. Okay, so first way of getting your answer is imagine this is a factor. How do I find the other factor? So let's say I give you this number, 108. I tell you 3 is one of the factor. How do you find another factor? You divide, right? 108 divided by 3, you get another factor, right? So same thing here. How do I find what time x minus 4 will give me this? I just do my division, right? So just do your long division. X minus 4. Of course, you can also compare coefficient if you know how to do it. Okay, so first thing 9x squared. So 9x cubed minus 36x squared. Okay, there's a sub minus here. So this becomes plus 36x squared. So it becomes 6x squared minus 23x minus 4. Then plus 6x. So there's a minus here again. So this become plus 24, it become x minus 4. So this kind when you do your long division, it must be equal to 0. The remainder must be 0 because it's a factor. Okay, so you can see now, oh, now I know that x minus 4 must times this to give me that. So now it becomes something times something equals 0, means this is equal 0 or this is equal to 0. You can see that you know how to solve them already. This is just x equals to. How to solve this? Factorize 3x plus 1, 3x plus 1. And you can see that the answer for here is x equals to negative 1/3. So solve this. These are my two answers. Okay, hence using your answer in part 2, solve the equation of this. Write out the question. Your C is, your A is negative 30. Your B is negative. So compare these two. What is the similarity? Oh, the 9 is the same. So we always compare the coefficient. 30 and 30 same. So how do I change this to look like that? I let x squared be equals to y. So x6 will just be y cubed. x4 will just be y squared. X squared will just become y. So can you see that this and this now is the same equation, just that this is x, this is y. So I don't need to go through this long division. I don't need to go through all this. I can straight away just say that my y is 4 or y is negative 1/3. However, is the question asking you to solve for x or y? They asked me to solve for x, not y. So I need to change back my y to x squared. Okay, x squared equals to negative 1/3, got no answer. You cannot square root negative number. Over here, when you square root, there will be plus minus 2. So this is the answer for part C, plus minus. You have to hence means you have to use your part B. And when did I use my part B? This is the part where part B is being utilized. Okay, instead of me solving all this, doing long division, I just copy down these two answers. This is the hence part which I have, the hence. Okay, any questions so far? So this is using substitution to make it look like the equation that you have solved just now. Okay, let's move on. Can move on, or copy already. 5, 4, 3, 2, 1, 0. Okay, so yeah, these two questions is also to solve your quadratic equation. Next, partial fraction. That's the last part of your polynomial. So first thing first, always remember that you may need to do long division if improper fraction. What is improper fraction? The power of numerator actually is called the degree lah. Okay, is greater or equals to the power of denominator. Equal you also need to do. Okay, once it is greater or equals to means you need to do your long division first before you write down your identities. And these are the three identities that we have. Okay, so let me do an example for you. So in this case, the power of the numerator is 3, the power of the denominator is 3. This means that I need to do long division. Okay, there's a minus here. So this becomes 2x squared minus 1. That's it. You cannot proceed further because this is x cubed and this is x squared. So what I know is I will know that this thing is actually equals to, okay, if you forget how to write, go back to your primary school. 5 divided by 3 is actually 5 over 3. 5 over 3 is actually 1 plus 2/3. Correct? So imagine you do long division. The 1 will come here. The 2 will come here. The 3 will come here. So what do we have? The 2 will be here. The remainder will be here. The denominator will be here. Okay, so first thing done. Now, what do? I only do partial fraction to this part. Okay, so to do partial fraction to this part, you need to factorize your denominator first. Factorize denominator become x minus 1. Then you can write down your identity. X squared will be a over x plus b over x squared. X minus 1 will be c x minus 1. Okay, then make the denominator the same. So a will multiply by x minus 1. B will multiply by x minus 1. It will be multiplied by x squared. So now we let x be certain values. So when x is 1, 1 is equal to c. We find c. When x is 0, -1 is equals to negative b. So b equals to 1. Okay, last but not least, you can just let x be any number. I let it be 2. So 2, 4, 8, 8 minus 1 equals to 2a plus b plus 4c. So you know what is b? B is 1. Is 1 also. So 2a equals to 2. Okay, once you do it, you remember to conclude. Therefore, this over x cubed minus x squared is equals to, remember to put in the 2. 2 plus 1 over x plus 1 over x squared plus everything 1 over x. So nice. Okay. Any questions so far?
对，这个 why 那个 is a over x for the partial fraction that part.
因为是 x square what? Repeated. You use the second one.
Okay.
Okay, so partial fraction, as some of you, or actually most of you have done it, you will see that you will do it again in integration. So imagine you cannot do partial fraction, cannot do the rest of the question already. Actually, only the first session is longer. The first worksheet is very, very long. The rest of the worksheet are short. The second worksheet only got how many pages? Okay, can I carry on? Carry on. Okay, so the last part for today, I think so, is your binomial. So, important thing, binomial formula is given to you in the formula sheet already. So this is the binomial formula you see lah. And then in the formula sheet, this is your general term. Okay. And last but not least, you need to know how to write all this into algebra. So 12 3 means 12 times 11 times 10 over 1 times 2 times 3. 12 4 means what? 12 times 11 times 10 times 9 over 1 times 2 times 3 times 4. Okay. What does 11 2 means? 11 2 means 11 times 10 over 1 times 2. The on top keep decreasing, the bottom keep increasing. Okay, 2 means there's only 2 terms. 4 means I should have 4 terms. 3 means I should have 3 terms. Okay, so when do we just expand? When do we use general term? When do we use this thing? So when do you use this thing? Typically when the power is unknown. This thing don't know, you don't know this thing. So you normally have to use this. Okay, when do we use general term? When your expansion is not the first few term, you use general term. If the term that you want to find is at the start, then you don't need to use general term. Okay, general term is for you. Imagine you expand this. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Imagine you want to find this term. Are you going to expand all this just to find this term? No, right? So we can straight away use general term to jump to this term. Okay. However, if I want to find the thing is just this 3 term, do you think I need to go and use general term to find 3 term? No, I just immediately expand. I get my 3 term faster. Okay, so that's the difference when we use general term when we just expand. Okay, so general term is a bit troublesome, but it's very good at pinpointing those that are very deep inside the expansion. Okay, however, it's very time consuming if you want to find the first 3 term or first 2 term. Okay, so let's take a look how we apply all this. First example, write down the first three terms in the expansion. So you know it's just the first three terms. You don't need to go and use your general term to write down my first three terms. Okay, so using the formula, how to expand? The first one is what? 6, 0. Always start from 0, 2 to the power of 6. Negative x over 3 to the power of 0. 6, 1. 2 to the power of 5. The power will keep decreasing. The other power will keep increasing. So now become 1. The next one, 6, 2. So remember, every term will have three things. 1, 2, 3. 1, 2, 3. 2 to the power of 4. Negative x over 3 squared. So now I have three terms already. So just need to simplify. 6, 0 is actually 0. This 2 to the power of 6 is 64. 6 is 6. 6, 2, this is also 64. But this is minus 64x. Okay, and this one, 6, 2 is 15 by 15. I press calculator. 15 times 16. 240 divided by 9. 80 over 3 x squared. Okay, it's positive because negative become positive. So this is the first three term of the expansion. Part 2, find the term independent of x in this expansion. What does term independent of x means? Term independent of x means don't have x value. Okay, so what you need to do is actually you need to go and do expansion because it's 2, so you need to do the rainbow multiplication, correct? However, we can't do that because this one got power 2, this one got power 6. So what we do, we expand this one because it's easier to expand. It becomes this square minus 2ab plus b squared. This becomes minus 8 plus x squared. Okay, so inside this thing there are 7 terms. Do you think you need to have all the 7 terms to find the independent of x? No, because we must realize, oh, what time this will remove the x? I need to have x squared. What time this will not give me x, a number? What time this will not give me an x to the power of negative 2? Okay, but you can see in this expansion, there will be no x negative 2 1. It will just become x cubed x4. The next one will be x cubed. The next one will be x4. The next one will be x5 until x6. So you can see that actually this is useless. This is useless. I do not need to put all this inside here. So what we do is typically we write what is needed only. So instead of me writing the 7 terms here, I just write down 64 minus 64x plus 80 over 3x squared. Of course, there are still terms, but I don't write. So the term independent of x is just 64 times negative 8, right? Plus x squared times 16 over x squared. Because the x and x will cancel. So it becomes 80 over 3 times 6. Just like that. That is your answer already.
Wait, term independent of x, x to the power of 0.
Yeah. So the answer will be negative 256 over 3. Okay. This x squared times x we don't do because it becomes x doesn't become term independent of x. Okay, term independent of x means there should not be any x when you multiply. So like 64 times negative 8, there's no x. 80 over 3x squared times 16 become 80 over 3 times 16. The x squared also not there. So because it's 3 marks, so you don't have the time to go and expand everything and slowly find out what are the terms that are independent of x. You must straight away see, oh, what do I need? Okay, so in binomial, typically do what you need, don't do everything. Okay, can I move on? Okay, let's move on. Next example, find the term independent of x in the expansion of this. So you can see that, oh, if I go and expand the first three terms, I expand the first few terms. Oh, the first one will be 9, 0, 2x squared to the power 9, 1 over x to the power 0 plus 9, 1. Do you know which one is the one that is independent of x? How long more do I need to do to get my independent of x? Do I know? I will not know, right? It may be very time consuming for me to keep expanding and expanding and expanding. But if you really don't know how to use general term, just keep expanding. You can get your answer also. Okay, so it's right, it's too time consuming. We will not know which one will give me term independent of x. That is where we use our general term. Okay, so you must understand that when we do what? When you realize that, oh, I do not know expand until which term will give me term independent of x. So the general term will be this 9r. The r we don't know one. That's the term that we try to find. 2x squared to the power 9 minus r, 1 over x to the power r. Okay, so the idea of general term is you need to separate all the numbers and all the x. So this will become 2 to the power 9 minus r, x squared to the power 9 minus r. This one bring up become x to the power negative 1 r. So these two are numbers. Never mind, so distribute first. So these two are x, we combine them together, become 18 minus. So these are your terms. So now we want x to the power 0. So in these three, this or this will contribute to my x to the power 0. Only this one, right? So I say, oh, this must be equals to x to the power 0. Then 18 minus 3r will be equals to 0. R will be 6. So r is 6. That will give me my independent of x. So when r is 6, so the term independent of x is put the r back into here, so 9, 6 to the power of 9 minus 6. That's it. Because you put here 0, so I don't write. Okay? So what is the answer? 84 times 8. 6, 7. Okay? Part 2, hence find the coefficient of x cubed in the expansion. So to find x cubed, what do I need? So I need a number from here, right? I need x to the power 0 from here, right? I need the x to the power 0. Why? Because x to the power 0 times 2x cubed will give me the x cubed term. And I also need the x to the power of 9 term. Okay, so that when I multiply with the x to the power negative this term, I will get my x cubed. So now I need to find x to the power 9. So how to find x to the power 9? I use back my general term. X 18 minus 3r equals to x to the power 9. 18 minus 3r equals to 9, r equals to 3. So now my r equals to 3 will be my x to the power of 9 term. So we will have x is 3, we will have 9, 3 to the power of 6, x 9, which is equals to.
How you get the x to the power 0 plus x to the power 9?
Huh? What?
The x to the power 0 plus x to the power 9.
I want x cubed. What time this will give me x cubed?
1.
0.
Why?
X to the power of 1 times x cubed give me x to the power of 4.
Oh. Then the x to the power 9.
X to the power of 9 times this x to the power of 6 at the denominator will give me x cubed.
Oh, okay.
You must identify these two things. If you cannot identify which are the power you need in this whole expansion, in this whole expansion, there are 10 terms, you know. So you are going to write all the 10 terms out and see which one multiply with these two will give me x cubed. You do not have the time to do it for 3 marks. So this is 5376x to the power of 9. So now I know this expansion will be this 672 plus 5376x9 times 2x cubed times minus 1 over 12x6. Okay, so I don't need to write everything down in this expansion. This expansion got 10 things, but the other 8 things are useless. I only need these two. So the coefficient of x cubed is just 672 times 2 plus 5376 times negative 1 over 12. The answer will just be 896. Okay, so in binomial, you can see clearly that, oh, I only choose those things that I need. Otherwise, you don't have time to expand everything. Okay. So very straightforward. You want to find what, I give you what. I won't give you extra thing. That's all. Okay, any question? If not, I will move on. Okay, the last example, as you can see, the power of n, the power of the binomial is not known. Okay, write down and simplify in descending power of x the first 3 terms of the expansion. So it will be n0 x5 to the power of n 2 over x6 to the power of 0 plus n1 x5 n minus 1 2 over x6 to the power of 1 plus n2 x to the power of 5 n minus 2 2 over x6. So simplify this. n0 is just 1. So this first one is just x to the power of 5n. Okay, n1 is just n. So we will have n times x to the power of 5n minus 5. This will be 2 over x6 plus n2 is just n minus 1 over 1 times 2. The on top power keep decreasing, the denominator keep increasing. This will be x to the power of 5n minus 10. Then over here we have 4 over x12. Okay, we still need to further simplify, not just leave it as it is. So this will be 2n x to the power of 5n minus 11. plus, so this 2 and this will cancel, become 2. So it becomes 2n, n minus 1, x, 5n minus 20. Okay, you have to simplify until like that. Always simplify your work even they never ask you to simplify, because it's easier to proceed if they ask you to carry on from here. Okay, so this is part A. Part B, when the third term is divided by the second term. So third term divided by the second term, they say is equals to 8 over x to the power 11. So over here, the 2n and 2n can cancel. And then this become n minus 1. This divided by this become x to the power negative 11. So this is actually 8 to the power x to the power negative 11. So from here, we can see that n minus 1 is actually equals to 8 and n is equals to 9. Okay, part C, using the value of n found in part 2 without expanding, show that there is no constant term. So you cannot expand already. The only way for you to show is to use general term, because you cannot expand. So the general term is equals to 9r So again, separate the r and separate the numbers and x. So this is 45 minus 5r. This will be 2 to the power of r, 1 over x, 6 to the power of r. Okay, I bring the number in front. Okay, this is x to the power of negative 6. Then I combine these two together. And you get 45 minus 11r. So we assume that the constant term appear. Constant term means x to the power of 0. Okay, so my x to the power of 45 minus 11r is equal to x to the power of 0. So 45 minus 11r equals to 0. R will be equal to 45 over 11. So since r is not a whole number, because r represents the term, okay? R is related to the term. You cannot have 45 over 11 term. R is not a whole number. The constant term does not exist. Okay? Any question? Okay, if not, then I will stop here.